a really good image of my golden retriever playing on the moon.
And we did it on a Mac.
Oh, nice.
That's a shame. All right, guys. So go ahead. You can, if you want, you can do it from here. I'll make you sit here and talk.
Okay.
And the microphone is hotter. Remember that.
Okay. Wait, just me? Okay.
Okay.
You want to go to the website first? Website first? Okay. I'll do that. You talk about it.
All right. So we decided to go start from the Hugging Face Diffusers website. And we thought, okay, as we were coding it, we should also start understanding the code. So we started from the understanding pipelines, models, and schedulers. And we were doing pretty fine for the initial part. And then we ran into network issues. We got over that. We were running it both in a Mac and our server here. We managed to get pushed through that. Eventually, what happened was all of us had CUDA problems. So we ended up running it on a CPU, unfortunately. But in spite of that, I think it's not being shared.
Is that?
Oh, I'll take care of it.
Someone else's.
When you share your screen, what you need to do is, what is this?
You just slide back to the side.
I think it's.
Figure you were looking at the camera earlier.
Now you share your screen. Oh, sorry.
It is shared.
Yeah.
Much better.
Okay. Cool. Okay.
So anyway, we ran it in a CPU. It was actually not too bad. We were surprised that in spite it was generating images pretty well. So that part became all right. What ended up happening was we used this one particular model and scheduler. So we used the stable diffusion 1.4 as well as the UniPC multi-step scheduler. So we didn't go too crazy on changing the schedulers and model like we originally thought.
I tried a couple of different models actually.
All right.
But outside I understand.
Okay. So this is the model that we shared, and you want to go to the Slack now? We can start showing the pictures.
Okay.
So we tried multiple ones. Again, we were doing it in Mac and our Linux server. So this is I believe from the Mac. So a farm of supercomputers on a beach. It did pretty well. The next one was software engineers without a job. We wanted to see if it could do anything. It was terrible. We have no idea what it did. Next was monkey on a trampoline, fairly good. And then this was probably our best one, a fluffy blue creature in a verdant forest. So I got this prompt from the three blue, one brown transformer video. Nice. So it did pretty well. What else? Astronaut on the depth of an ocean.
And then I tried an engineering-ish question on showing grain boundaries on annealing steel and tried an elaborate prompt. And this was kind of interesting in the sense of it seems like it's showing me a computer screen, like a SEM. But I'm kind of curious because I didn't mention anything about that, but then it tries to generate like this is how you'll see the grain boundaries.
Yes.
So that was kind of interesting.
It is actually fairly accurate.
This is how it is with a more simple prompt. So the simple prompt of like, hey, grain boundary, and then the more complex prompt. And then
this was the woods are lovely, dark and deep. We have fairly conventional image, I think.
And then trying a different diffusion model with another blue fluffy creature, we get this kind of a different take on the same prompt. So that was kind of cool. And then Vishal from listening. And then after that, I tried playing with the amount of steps, so the time steps that we were given. So if we have the same blue fluffy creature prompt and reduce this time steps, then it gets kind of fuzzy. if I then increase I tried the same complex prompt, but with instead of engineering with a cat. And then one thing that I realized is the more steps you give it, the more descriptive it becomes of the prompt. So like in the prompt, I have like white marble, fridge, avocado, but you don't see any of that here. And then if I increase the steps to 25, now you see a fridge, now you see the avocado, but you don't see the white marble, right? You don't see the inside of the fridge. So it's one of those, the more you increase the
25 steps. Why did you try for 500 steps?
I was trying 100 to see if it popped up. Oh, same thing with 100 steps.
500 to 1,000. Change it to 1,000 and run it on the server.
Oh, actually, it's still running. Yeah, we couldn't figure out how to do it on the server, so I'm doing it on my CPU right now.
I'm going to take that server back from you guys.
We had CUDA problems. It wouldn't.
Yeah, so instead we did it on 6 laptops. So
Mac and Linux.
So sorry, it's not a CUDA problem, right? The model, we are not clear about that. The model, when we ran it, it complained about it ran only in CPU or something. Was it right?
Then you have to use a model that is GPU.
There's a the code, if you were
never use a model that's created for the CPU.
Yeah, that's probably the wrong thing.
Optimization.
Okay. If you were using the code from the example, there was the generator was not instantiated in a way that it could use the GPU. There's just a slight modification you have to make on the code, and then it'll run on the CUDA for that.
Okay, that's what.
You post the update in Slack, please. Right?
Yeah, I'll push out my notebook that has that code segment. It's just inside of where you define the generator. You have to define it lower with running it as a CUDA execution. I'll post that line in the Slack channel here.
Right, thank you.
Thanks.
And this is the final golden retriever playing on the moon.
This looks so uncannily like my dog.
And then this is just the code that we were running through from that example. Do you want me to run through the notebook or?
No, this is good.
Okay.
I know this code.
Cool.
Inactive condition.
Thank you, guys.
Very good. And which Prasanna's team? You're ready? Come by. From here itself. So I will stop this one.